One of the most basic truths about our solar system is all but ignored by evolutionists. Our sun's diameter is shrinking at a rate of 5 feet per hour. At this rate, it shrinks at about 0.1% per century. Calculating backwards, the Earth would be inside the Sun less than 25 million years ago. Additionally, the Sun burns its fuel, losing mass at a rate of nearly 43 million kilograms every second. This loss of mass should have eventually produced such a loss in gravitation that the planet would be further away from the Sun or even have escaped the solar system altogether. The physics just don't support evolution. Let's see if the so-called scientists can explain this away. I had to investigate. It may shock you to find out that this creationist argument is based on a peer-reviewed paper. In June 1979, respected solar astronomer John Eddy and his colleague Amram Boornazian presented a preliminary paper to a meeting of the American Astronomical Society. They presented measurements taken from 1836 to 1953. During that time period, analysis of solar meridian transit data from the Royal Greenwich Observatory showed that the Sun's angular diameter seemed to have been contracting at a rate of 2 arc-seconds per century, equivalent to 5 feet per hour. This measurement was strengthened by citing a 1567 report of a solar eclipse suggesting that it was not total. It is important to note that this was the moment when the paper was submitted for peer review. Immediately after, the conclusions of Eddy and Boornazian were challenged. That same month, Sabatino, Sofia, John O'Keefe, and their team, all from Goddard Space Flight Center, published an article in Science detailing their own observations. They also used observations of the Sun's transit through the meridians to measure the fluctuations of the size of the Sun. They determined that the Sun's angular diameter did not diminish by more than 0.5 arcseconds between 1850 and 1937. The next year, Irwin Shapiro used observations of Mercury's transit across the Sun made between 1736 and 1973 to publish an article in Science. The measurements he studied indicated a shrinkage of less than 0.3 arcseconds per century. That same year, David W. Dunham published measurements of eclipses from 1715 to 1979 and determined that there was less than 0.25 arcseconds change per century. Again, these results appeared in Science. This, in turn, led to John H. Parkinson, Leslie V. Morrison, and F. Richard Stephenson double-checking the work by Eddy and Boornazian and determined the discrepancies in conclusions were caused by imperfect and antiquated tools for measurement as well as atmospheric disturbance, partially resulting from the Industrial Revolution. These conclusions were published in the December 1980 issue of Nature. Also in this paper, the team analyzed the work in the subsequent papers and noticed a cyclical trend of shrinking and expanding every 76 years. In 1983, John H. Parkinson and S. Sofia both published papers evaluating past observations and incorporating new data, such as the total eclipse in 1981, and independently confirmed the conclusions of Parkinson, Morrison, and Stephenson. There simply was no overall change in the Sun's diameter indicated by all the data available. The final nail in the coffin for the Sun shrinking argument came in a 1984 paper by Claus, Frohlich, and John Eddy, one of the two original authors of the initial Sun shrinkage paper, which was presented at the COSPAR Scientific Assembly. While making observations of the correlation between solar diameter and luminosity, the pair noticed an expansion of 0.03 arcseconds per year between 1967 and 1980. The shrinking Sun argument was put to rest. This seems counterintuitive, though. The Sun loses 43 million kilograms of mass every second. How could it not be shrinking? It is important to note that mass can affect the size of an object, but the two terms are far from synonymous, especially on astronomical scales. For example, a neutron star is at least 1.4 times the mass of our Sun, yet is much smaller than the planet Earth. The most massive neutron stars, known as magnetars, are up to 3 times the mass of our Sun and yet are only 20 kilometers in diameter. Black holes, the most massive objects we know of, are so small that they defy measurement. We refer to them as a singularity, having location but no size. In the case of the Sun, the differential between mass and size is held steady by the amount of energy pushing outward versus the gravity pulling it inward. But that still leaves the question of mass with relation to Earth's orbit. If the sun was more massive in the past, the effect of gravity would have been stronger. As the mass of the sun decreases, it would have less gravity pulling on the planet. The velocity of Earth's orbit should then cause it to recede or leave the solar system completely. As I said before, the sun loses 43 million kilograms of mass every second. When a star uses fuel, it is fusing hydrogen nuclei into helium. While there is a release of energy, the helium remains gravitationally trapped in the star. The energy is released in the form of heat and photons, which begin their 100-year journey to the surface. Now, break out your calculator. Although the rate isn't constant, if we assume the current rate of 43 million kilograms every second, times 60 seconds, times 60 minutes, times 24 hours, times 365 days, we arrive at a figure of 1.353 times 10 to the power of 17 kilograms every year. This seems like a big number, but if we multiply it by 5 billion years, we get 6.78 times 10 to the 24th kilograms. The sun's current mass is 1.989 times 10 to the 30th kilograms. What this means is, even if the rate of loss were 100 times greater, the sun would still only be a fraction of a percent less massive over 5 billion years. This would hardly have a dramatic effect on Earth's orbit. The question of mass is simple arithmetic, albeit with giant numbers. But as I've repeatedly addressed in this series, peer review is where science is validated. Although the shrinking sun argument stems from a peer-reviewed source, when Eddy and Boornazian presented their work to the American Astronomical Society, they were submitting it for peer review. As Eddy later conceded in 1984, their work simply didn't survive it. And that's another example of how creationism taught me real science.
Learn more about the real science behind other creationist arguments by watching other episodes. If there's a creationist argument you think I should investigate, please comment below. It may be the subject of a later video. In the meantime, subscribe and make sure you don't miss it.